Hello, everyone. Welcome to our webinar. Today, we are going to discuss how to construct quantitative research questions and hypotheses. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. We'll send everyone a copy of the PowerPoint as well as a copy of the webinar. If you have any questions, you can type them into the chat box or the Q&A box, and we'll do a question and answer session at the end of the webinar. My colleague Sierra is also providing some hyperlinks in the chat box for dissertation resources and our company website, so you can take a look at those. And just let us know if you have any questions. All right. So first, I'll give an overview on the services that we provide at our company, Statistics Solutions. Then we'll discuss how to construct research questions and hypotheses, have a summary, and a question and answer session at the end. On this slide, you can see all the various parts of the dissertation journey that we assist with, starting with topic development, going all the way to final defense and journal publications. We have literature review specialists at our company, as well as quantitative and qualitative methodologists. So, if you need help framing your research questions or your purpose and problem statement, finding literature to support your topic, even establishing a gap in the literature at the very beginning, we can help you with that. And then we also assist with the actual crunching of the numbers. So once you gather your data, you can send it to us along with your template for your school, and we can provide an APA write-up for your results. And then we help with the discussion chapter, which is kind of wrapping up your dissertation, and then PowerPoints for proposal and final defenses. And we can help, we can help to condense your dissertation into a journal publication. So if you have any questions about the services we provide, you can give us a call at 727-442-4290, or you can schedule a free consultation using the link that Sierra provided in the chat box. On this slide, you can see the past webinars we've done and the recordings at the webinar archive, and you can see the upcoming webinars that we're doing in the future at the top link here. And let's dive in. All right, so we're focusing on research questions, specifically quantitative for this webinar. And before we get to that, it's important to lay the foundation for what's the difference between quantitative and qualitative. So quantitative, just like it sounds, includes quantitative numbers. Usually you need to run statistics to address your research questions, whereas qualitative is more open-ended. It's looking at subjective interpretations, subjective perceptions, usually open-ended responses, which involves running an interview of some sort and then thematizing the responses. Some studies use both. So you might be doing a mixed method study in which you need to have separate sections in your paper for the quantitative component and then separate paragraphs or sections for the qualitative component. Before getting into your research questions, first you need to pinpoint your research problem. You don't want to jump right into research questions and figuring out what analyses you need to run. There needs to be a gap in the literature first. So you need to pick a topic, or you need to have a study that is providing something unique literature. And then after you've pinpointed your research problem and the gap in the literature, I recommend creating a list of all the variables of interest for your topic and pinpoint, are these variables numeric? Are they multiple choice? Is it based on a Likert scale? Are you using archival data? Are they independent or dependent variables? Things like that. And then the research questions can be framed in a specific format based on the research design that you're selecting. These are the 4 most common research designs that I see for dissertations. So we have descriptive and exploratory, we have correlational, we have experimental, quasi-experimental, causal comparative. Those kind of all go into one branch. And then we have longitudinal studies. So we'll look at each of these designs and the types of questions that you can frame for these specific designs. All right, first we'll look at a descriptive or exploratory design. These are the most simplistic. Sometimes committees will not be on board with this because it's a little too simplistic for a dissertation. But if they are on board, by all means, proceed with this approach because it's fairly easy. So for a descriptive or exploratory design, you're not trying to prove that there are relationships or prove that there are differences between groups. You're just examining the trends in your sample. Here we have two sample questions. So what are the trends in job satisfaction among teaching faculty? Or what is the predominant leadership style used among managers in a workplace? You can see that we aren't correlating or associating variables together. We're not looking at differences or comparing variables between groups. It's just a general overview of how people responded to a survey, or a general idea of how people are scoring with archival data. So we're not relating anything, not looking at differences. And typically you would use descriptive statistics to address these questions. So looking at things like frequencies and percentages of responses or means and standard deviations of variables. Correlational research is one of the more common approaches. Okay, so a correlational design is an umbrella concept that encompasses the use of both correlational analyses and regression analyses. That might sound a little confusing. I've put together a diagram here to kind of visualize this. So when I say umbrella concept, correlational design is at the very top, and this branches out into specific analyses. So you can run correlational analyses under a correlational design, or you can run predictive analyses under a correlational design. So you can see the specific types of analyses you could run: Pearson, Spearman, chi-squares for correlational analyses, and then regressions are usually the approach if you're predicting. Okay, first we'll look at the correlational design, or rather the correlational analyses. And when you're doing these analyses, it's not required that you have independent and dependent variables. You can, but it's not imperative. You just need two variables of interest. So here we have some sample questions. In general, this is the template you want to follow. Is there a significant relationship or association between X and Y being your variables of interest? And then we have two examples here. So is there a significant relationship between age and self-efficacy, or is there a significant association between education and job position? Now, the level of measurement for your variables is going to pinpoint what analysis you need to run. So most variables will fall into three categories. You can have continuous variables, you can have ordinal variables, or you can have categorical variables. So continuous variables are any variables that are strictly numeric. If they have decimals as possibilities, they fall in an interval or their ratio. That's when you can do Pearson correlations. So Pearson correlations are used when you have two continuous variables of interest. Spearman correlations are used when you have one ordinal measurement, at least one ordinal measurement. So if that was like a multiple choice item on a questionnaire, like a single Likert scale item, strongly agree to strongly disagree, that would be an ordinal item. Or something like education level, where you have high school, associates, bachelor's, master's, PhD. That's an ordinal variable because it goes up a hierarchy. If you have two categorical factors, then you can do a chi-square test of independence. So factors like gender or ethnicity or passing and failing an exam, those are not numeric, those are categorical. So if you have two categorical factors, you can do a chi-square test. Categorical and nominal mean the same thing. Right. And here we have some examples of research questions for a correlational analysis. You can see, is there a significant relationship between age and self-efficacy? you're going to have typically a null hypothesis and an alternative hypothesis. The null hypothesis usually states that there's not a significant relationship or there's not a significant difference between groups. And the alternative is what you're trying to prove. So there is a significant relationship. So you can see they're phrased almost exactly the same way. We're just adding the not for the null. And likewise for RQ2, similar phrasing. So usually in statistics, you're trying to disprove the null and prove that the alternative is accurate. So going back to our diagram here, we just looked at correlational analyses. We'll now look at predictive analyses, which fall under the correlational design as well. So if you're doing a predictive approach, then you're most likely going to run regressions. If you see the word predict, you can pretty much assume that regressions need to be run. And when you do a regression, you need to have an independent variable and you need to have a dependent variable. The terminology kind of changes here. You can see it called a predictor variable for the independent and a criterion variable for the dependent. And the phrasing of the questions is very similar. All we're adding is the predictive word in here. So is there a significant predictive relationship between X and Y? And we have 3 examples here. And similar to the correlations back here on the previous slide, the level of measurement is going to pinpoint what analysis you can run. So again, continuous variables or anything that are numeric, that are interval or ratio. So if your dependent variable is continuous, then you can run a linear regression. Now, question 1 up here, sample question 1, is there a significant predictive relationship between age and self-efficacy? If self-efficacy is being measured by a previously validated instrument and you're building a composite score from that, from hypothetically Likert scale responses, then you can run a linear regression. Research question 2, does emotional exhaustion, depersonalization, personal accomplishment predict academic performance? Because we have multiple predictors, we have multiple independent variables, you can run a multiple linear regression. So just a simple linear regression means you have one predictor, which aligns with the first question here. The second question, you would use a multiple regression, multiple linear regression specifically, because you have multiple predictors or multiple independent factors. If you have an outcome or a dependent variable that's dichotomous or binary, then you can run a binary logistic regression. So if you were trying to predict passing and failing of an exam, as we're doing in the third question here, you can do a binary logistic regression, but you have to have only 2 distinct groups. You can't have 3 or more. If you have 3 or more, then you can run a multinomial logistic regression. So that could be used to predict a categorical factor like race. If you have multiple responses for race, white, Asian, Black, Hispanic, something like that, then you could use a multinomial logistic regression. And then we have an ordinal logistic regression. This is kind of a rare scenario, but sometimes you have an outcome or a dependent variable that is strictly ordinal, like a single Likert scale response, or maybe education levels, what you're trying to predict. Then you can do an ordinal logistic regression. So here we have these sample hypotheses phrased in a very similar way. There is not a significant predictive relationship. There is a significant predictive relationship for the null and alternative respectively. And that's it for the correlational design. All right, so then we're going to transition to experimental, quasi-experimental, causal comparative. I put those all together because usually the goal is to look at differences if you're using a design like that. The differences is the key word. We're comparing values between groups. Okay, so the independent variable is going to be your grouping factor, whether that's treatment control groups, gender, ethnicity. It has to be a categorical grouping factor. And then the dependent variable is the value or the variable that you're trying to assess for differences between. So here we have some sample questions. And as I said, the key word is difference here. So just running back through them, correlations, we used relationship or association for the verb. And then we have predictive relationship for regressions. And now we're using differences for experimental type designs. The way you phrase this is you would say, is there a significant difference in Y, which is your dependent variable, between the groups of X? Here we have 4 examples. And if you're only comparing 2 groups, males and females or treatment and control groups, you can run an independent sample t-test. So that would apply to research question 1 up here. Is there a significant difference in job satisfaction? That's your dependent variable between 2 groups. So you can do an independent sample t-test when you only have 2 groups. If you have 3 or more groups to compare, then you can run an ANOVA. That's an analysis of variance. So that would apply to question 2 here. Is there a significant difference in self-efficacy based on race? Assuming race has more than 3 possibilities or 3 or more possibilities, then you can run an ANOVA. Question 3, we have 3 dependent variables, not just 1. We have emotional exhaustion, depersonalization, personal accomplishment. So if you have more than 1 dependent variable, then you can run a MANOVA. So that's a multivariate analysis of variance. That just means you have multiple dependent factors. And then you can also run an ANCOVA or a MANCOVA potentially. So the C here stands for covariance. So an analysis of covariance or a multivariate analysis of covariance. So this is used when you're introducing a third factor to your study that you want to control for. So that would apply to question 4 here. Are there significant differences in these factors based on race while controlling for job satisfaction? So essentially what that's doing is it's holding job satisfaction constant in your model, and it's seeing if there are still differences in your key variables by race. All right, here we have sample questions and hypotheses. Very similar, we're just saying there's not a significant difference for the null hypothesis, and the alternative, there is a significant difference. All right, I organized question 2 a little bit differently because we have 3 dependent variables. So is there a significant difference in emotional exhaustion, depersonalization, personal accomplishment by race? I would build a separate hypothesis for each of these, or a separate sub-hypothesis more specifically. So 1 hypothesis per variable. So emotional exhaustion gets 1, depersonalization gets 1, personal accomplishment gets 1 as well. And then the final design type we have is a longitudinal design. So this is used when you're running pre and post comparisons. If you're doing a pre-test, then an intervention, and then a post-test. You need to have the same participants returning for this to work. So you need to match your IDs. If that's done with the email address, or maybe you give each person an ID at pre-test and they have to enter that ID at post-test, you have to match your individuals to run this. So there can be an overlap with experimental designs for this. So you could be running an intervention, treatment and control groups. And in addition to that, be running a pre-test and post-test. So a lot of moving parts if you're doing that, and we'll look at it more specifically. So the independent grouping factor could be your treatment control, or males and females, or ethnicities. And the variable that you're looking for differences in is your dependent variable. Here we have some sample questions, and it's phrased in a similar way. Is there a significant difference in your dependent variable between times 1 and 2? So you could say pre-test and post-test here, or before the intervention and after the intervention. For a sample question, is there a significant difference in knowledge between pre-test and post-test of an educational intervention? Because we only have a pre and post for this, you can do a paired sample t-test. This is probably the most common analysis used for pre and post comparisons, especially in the nursing field. A lot of PICO questions involve looking at pre and post. However, if you're introducing more than 2 time points, say you have a pre-test or a baseline, then a post-test, and then a follow-up at some time in the future, you would have to do a repeated measures ANOVA for this. You can't just do a paired t-test because you have 3 or more points in time. And then we have a mixed model ANOVA. So this is the big one. This is if you're doing a true experimental study, and it's used if you're looking at differences in a variable between time and between groups. Sample question, this should say sample question 3. This would be a mixed model ANOVA. So we'll break that down a little bit more here. Here we have the null and alternative hypothesis for just the repeated measures ANOVA, baseline, post-test, follow-up. There is not a significant difference. There is a significant difference. And then if you're doing a true experimental study, you're going to have 3 different parts. All right, so is there a significant difference in knowledge over time? Is there a significant difference in knowledge between groups? And then is there a significant difference in knowledge between the combination of time and group? Okay, so if you're doing a true experimental study, you're going to have pre-test treatment, pre-test control, post-test treatment, post-test control. That's what this third hypothesis is testing, is all those different components, time and group put together. So in summary, identify your problem statement first. Don't jump right into research questions and data analyses. Figure out a meaningful topic, something that's contributing to the literature. Then pinpoint if you're using quantitative or qualitative or both. Identify the variables of interest for your study and the level of measurement. So are they nominal, are they ordinal, or are they interval? Something I would recommend is building a table. Let me build a hypothetical table here. So like this. Typically in the methodology, I recommend this to all my clients, is put the variable of interest here. Is it independent or dependent? What is the source in terms of, is it archival data, name of the instrument? Then put, we'll need a couple more columns here to put the level of measurement as well. Is it nominal, ordinal, or continuous? And then the final, I would put possible values. This could be, what do scores range from? 0 to 100, or if you're using a Likert scale, 1 to 5 maybe. If it's a categorical variable, is it just like male, female for gender, things like that. So once this gives a good picture of all the variables in your study, I would even add maybe a research question column here. So you could say, this corresponds to research question 1. This is research question 2, 3. This summarizes your entire data analysis plan, just in one table. So I would recommend doing this. Then you want to determine if you're going to use a survey or archival data. And if you're using a survey, try to pick one that's previously validated. Don't create your own survey if you can avoid that. It just adds months to the process. You have to do a pilot study and prove that it's valid. Archival data can also be tricky to find. Then you have to select your research design. Are you doing exploratory, correlational? Are you looking at differences between groups, or are you looking at differences over time? Then develop your research questions and hypotheses following the specific design. And then from there, you can pinpoint what analysis you need to run. All right, if we have any questions, you can type them into the chat box, and we'll send everyone a copy of the webinar as well as the PowerPoint. Thanks for joining, everyone. Let's see if we have any questions. Okay, a question from Diana. I'm just going to put the questions into a Word document here so everybody can see them. So about moderating, moderation. So this would fall more under the regression family. Right here. So if you're doing moderation, this falls under regressions because you need to run regressions to prove moderation. So to phrase a moderating question, it would be, you're going to have three components at least. You'll have your independent variable, have your dependent variable, and you'll have your moderator. The moderating question would be something like, does M significantly moderate the relationship between X and Y, right? Does M significantly moderate? So we have all three components here. We're trying to see if this moderator impacts the relationship between your independent and dependent variables, okay? It would take another webinar for me to go into depth about moderation. You have to create interaction terms and run hierarchical linear regression. So you might have to reach out for assistance if you need more support. All right, do we have any other questions? Okay, we have a question from Joan. Would you introduce propensity scoring in an observational study? I think the rest of your comment may have cut off. It stopped at specifically. Propensity scoring, I think that kind of goes with, I've seen that associated with ANOVAs and MANOVAs, so that might be, I'll have to do a quick Google search on this. I haven't used propensity scoring personally. Yeah. So yeah, it does fall under the quasi-experimental method. I think ANOVAs and MANOVAs or t-tests are typically used for this. Specifically parts on the matching variables. Yeah, I think you would have to do, that would fall under quasi-experimental, as it does say here. And I think you would run ANOVAs, t-tests, that sort of thing. And so I'm just not knowledgeable enough about propensity scoring, unfortunately. And we have a follow-up question. Moderating study and a predictive study the same? I do not typically see studies called moderating. Like, moderating is the analysis that you're using. Moderation is the analysis you're using. I would not consider them synonyms or the same. I would use predictive as your design. So I would say this study will use a quantitative predictive design with a moderation analysis, something like that. Okay. All right, do we have any other questions? Thanks for the feedback, Joan. Oh, I'm just seeing another question from Diana. Can we classify mixed methods as a research design? I have seen it called mixed methods collectively, but sometimes you need to pinpoint for the quantitative part, what is the design for the quantitative part? You might have, as we reviewed, you might have correlational, quasi-experimental, that sort of thing. Something like that. And then qualitative, you might have to identify the design for that, if that's phenomenology or grounded theory. I think that would be more accurate. You could call it mixed methods. Actually, I have the answer for this. So mixed methods is the methodology. Okay, so you can either have a quantitative methodology, you can have a qualitative methodology, or a mixed methods methodology. So that's your methodology. The design is going to be specific to what's underneath there. So for the quantitative component, you have to identify your design. And then for the qualitative component, identify your design. Does that make sense? All right, we have a question from Joan. I also come across the term non-parametric. Can you give an example? Sure. Okay, so if you propose to run a Pearson correlation, this is a parametric analysis because you need to have normally distributed variables. So you can, this is a great website you should check out. If you go to statistics, actually have it open right now. So statistics layered. If you type any analysis and check out this website, it will describe it. And if you're doing a Pearson correlation, you have to check for assumptions. Any parametric analysis, you need to check for assumptions. And one of the assumptions is that your data follows a normal distribution. So if this is not supported, then you can shift to a non-parametric technique, which would be a Spearman correlation. Parametric. Almost every analysis, excluding regressions, has a non-parametric alternative, like independent t-tests. You can run a Mann-Whitney U-test as a non-parametric. And we have paired t-tests. You can run a Wilcoxon sign rank test as a backup. So the idea is that you might propose a parametric analysis. You need to check the assumptions of that analysis, and you can find those on this website. I'll put the link in the chat box. So you check the assumptions of that analysis, and if they are not supported, then you can shift to a non-parametric technique, which would be Spearman, Mann-Whitney U-test, Wilcoxon, and ANOVA even has one as well. If you do an ANOVA, a non-parametric for this is a Kruskal-Wallis test. So there's almost always a backup non-parametric that you can run. All right, we have a question from Sam. Where does panel data fall into? I think this falls into the longitudinal family because it's collecting data over a period of time. And usually the same participants are returning when you're dealing with panel data. So I would consider it to be longitudinal. All right, we have a question from Giancarlo. How much can ChatGPT help with a dissertation? That's a great question. I imagine a lot today. It could probably write up a good portion of it. I would not trust ChatGPT for running statistics just yet. I don't think it's quite at that level to be trustworthy. I have run statistics in there and it has been accurate for the most part, but for an entire dissertation, I would not use ChatGPT. But it could be really useful for your literature review, I imagine. You could find articles. I don't know if it gives citations and stuff like that, but it could maybe give you articles to check out, you know? I think it could be very useful. All right, some good questions. We have any additional questions? We have a question from Juan. Can we use structural equation modeling for correlational studies, experimental studies? Yes, I think structural equation modeling falls into more the correlational design. My mouse just stopped working. 1 second. Not sure what happened there. Okay, yeah. I think, as I indicated on this diagram here, I think I deleted it. Oh yeah, this one here. So as I said, correlational designs at the very top. And I put path analysis here. So predictive analyses. Path analysis and structural equation modeling kind of go hand in hand. So I would consider structural equation modeling to be under the correlational design and under the predictive analyses family. All right. Any other questions? All right, we'll send everyone a copy of the webinar and the PowerPoint. Reach out to us if you have any assistance or any questions about the assistance that we offer. We help with every part of the dissertation journey. Give us a call at 727-442-4290 and have a great day. We'll be in touch.